So we need to evaluate this without a calculator so that we can give an exact answer. And looks like this one has two pieces to it. So I will come back to the cosine part, and I will first try to deal with this inverse tangent of 2. So this is asking what angle has a tangent of 2, and from all the stuff I memorized about the unit circle, that's not something that I memorize. So if this is not unit circle, then you've got to sketch a triangle to move forward. Okay, well, it does make a difference if you draw the triangle correctly. So think about inverse tangent. It's only interested in quadrants 1 and 4. So it would not make sense to make a triangle in quadrants 2 or 3. And this is positive 2. Tangent is positive in quadrant 1, negative in quadrant 2. So this is how I know that when I sketch my triangle, I want it to be in quadrant 1. So then I can say, alright, so here's an angle. Its opposite to its adjacent needs to be 2 to 1. And now I've got this. Inverse tangent of 2 is being visualized right here. This angle has an opposite to an adjacent of 2. Okay, so that's all I can really do for the inside, because I don't know an exact value for that. I don't memorize that, so the best I can do is draw a picture. But now I can apply this outside layer. What's the cosine of this? Well, cosine would be adjacent over hypotenuse. So, adjacent over hypotenuse. I don't know the hypotenuse, but of course, leg squared plus leg squared equals hypotenuse squared. Pythagorean theorem. It's not a Pythagorean triple, so you're probably going to need Pythagorean theorem there. I can figure out what the hypotenuse is. And since that's not rationalized, let's just go ahead and take one extra step. Multiply the top by the square root of 5 and the bottom by the square root of 5. And we end up with square root of 5 over 5.